In this video, we're going to look at solving quadratic equations using a method called completing the square. Now, a positive about the completing the square method is that it does work. For all quadratic equations. So if you've tried other strategies and they're not working, then this one will always work no matter the quadratic equation. It is a little bit more involved though. Another benefit of the completing the square is that it is used a lot with circles as well. And other similar shapes. So it is good to know this method too. You can see here on the left, there are quite a lot of steps though. So you may want to pause the video a couple times to write them down. And the steps will make more sense when we actually go through it. It's a little hard to understand just to read the words. But I'll read through them and then we'll look at a couple of examples. So for this one here, you set it up a little bit differently than we're used to. What we're going to do is have everything that has a variable on one side and everything without a variable on the other side. So for instance, on the left side of your equation, you should have like the x squared in the x term, and on the right side, you would have just a constant. The other thing we do look for here is we do like our x squared term to have a coefficient of 1 at the beginning. We really want that x squared term to have a coefficient of 1. So if it does not have a coefficient of 1 to start, like let's say it's 3x squared, we're going to divide by that 3 across the equation to get rid of it. The third step is where the completing the square idea comes in. So I will show you how to do this, but basically we complete the square by adding the square of half of the coefficient of the x term to both sides of the equation. And again, that will make more sense once you see it done in action. The reason we do it is because once you do that, we're able to actually factor very, very nicely. So that's the whole goal here, is that we can sort of add something to both sides of the equation to make the left side easily factorable. And then we will use the square root property to solve for x. If you have not watched the video on the square root property yet, make sure you watch that first before you go in and begin this video. All right, so here is an equation. It is in the correct form to start. So the biggest thing when you're completing the square is that all your variable pieces should be on one side and the number should be on the other. So that is really important that you start that way. The other thing is we do like to have our first coefficient here be a 1, which it is. So if there's nothing there, there's always a 1 there. But if there was something different there, we would want to divide it out. So this one is good to start. So I'm ready to go to step 3 now. So what do we mean when I say add half or the square of half the coefficient of x to both sides of the equation? So what you're going to do here is you're going to take whatever is with your basic variable, so not the square one, the other one, and you're going to cut it in half. So here it's going to be a 2. So again, you're always cutting in half. And then what you're going to do is you're going to take whatever that value is and square it. So here, 1/2 of 2 is just 1. So this becomes 1 squared, which is just 1. And then what you're going to do is you're going to rewrite your problem. And you're going to add this 1 to both sides. So again, the key thing is this piece right here. Whatever number is there, that is the one that you're cutting in half. You're squaring it, and then you're adding that to both sides. So that is the key idea here. Once you do that, so the right side here becomes 4 plus 1, which is 5. But the left side is going to factor into a perfect square. And it's going to look like this. It's going to be whatever your variable is, and then whatever the value here is. So whatever 1/2 of that value is. So this is the 1/2, in this case, 2. It will always factor that particular way. So whatever this is, half of it is what's going to be in the factored piece here. Now, why do we do all that work and manipulation? The goal is so that now I have something that I can use the square root property with. Notice that my variable now is all being squared. So what I can do is take the square root of both sides. Don't forget the plus or minus. And we have our solution. I'm going to subtract 1 to both sides, and p equals -1 plus or minus √5. And don't forget, these are two answers. You have -1 plus √5 and -1 minus √5. So those would be your two solutions here. So again, the process here is, first of all, variables on one side, number on the other. Whatever is with your plain variable, so not your square piece, your regular piece, you take half of that and you square it. That is what you add to both sides. What happens is one of those sides will factor perfectly as a square, and it's always going to be whatever your variable is, plus or minus, depending if it's positive or negative, whatever that half of that number is. So we'll factor that way. And then we're going to use the square root property to finish. So let's do another one. Okay. So here I do have to start. I need to bring this 1 to the other side. So I'm going to add it to both sides. And again, you want to always start such that you have the variables on one side and you have the number on the other. So that is key. The other thing you need to check is you need to make sure there is a 1 here, which there is. Otherwise, we'd have to divide by whatever coefficient is there. All right, so now let's start. I'm looking at whatever the term is, or the coefficient is with that, plain variable term. So the one that's not squared. So here I'm going to take 1/2 of it. And then I'm going to go ahead and square that. Now, 1/2 of 7, you can write this as 7/1. So this is just -7/2. I'm going to square that, and I have 49/4. So I'm going to go ahead, I'm going to add that to both sides. Right, so that's what I'm adding in. Always half of whatever the piece is left, and then squared. What happens is the left side is going to factor as m, and it's going to be whatever the half piece is before you square it. So it's going to be that -7/2. So it's whatever that is before it's been squared. That is what it factors as. And on the right side, you're going to have to do a little bit of work. So you may want to do this off to the side, right? The number 1 is the same thing as 4/4. 4 plus 49 is 53. So this right side becomes 53/4. And then what we'll do is we'll take the square root of both sides. Don't forget your plus and minus. Our left side is m minus 7/2 is equal to plus or minus the square root of 53/4. Now I can't do everything for the root here, but I can at least do the denominator, right? Because 4 is a perfect square. So that can cancel out to just be 2. And then I can go ahead and add my 7/2 to both sides. So m is 7/2 plus or minus the square root of, sorry, this was 53. Apologies about that, 53/2. And that's actually a correct way to write it. You could write it like that, or because they both have the same denominator, you could put them together and write it like this. That works too. And just remember that there are two separate answers here, right? So there is one that is the positive version, and there's one that is the negative version. And of course, these are just numbers. So I know they look kind of funny, but they are just real numbers. And as a side note here, let me find my calculator. You just want to be careful here when you have a more complex division like this. Do the numerator first, 7 plus the square root of 53, hit enter, and then do your dividing by 2. So if you're going to do it as one big group here, you're going to do the adding and then divide everything by 2. You could also do them separately. So you could do 7/2 plus root 53. Oh, let's try that again. 7/2 plus square root of 53/2 And again, you'll get the same answer, but you just want to be really careful that you're typing it into your calculator correctly. And of course, you can do the -1 the same way. So although these look funny, these are real answers. They're real numbers. As a side note too, just a little tip here. When you get things that have square roots on them like this that can't be simplified, these would actually be quadratics that could not be factored. So unless you get nice answers, you can kind of know that if you had tried another strategy first, like factoring, and it wasn't working, you were correct. So when you get these messy answers like this, it usually is a note that factoring would not have worked here. All right, and let's do one more. So I'm going to start by bringing 3 over. I'm going to subtract 3 from both sides. Now I do not want this 2 here, so I am going to divide everything by 2. So I'm technically dividing both sides, right, in completion. So every single term has to get divided by 2. That would give me x squared minus 4x equals -3/2. Now I'm ready to start. So remember, I take whatever number is with the x piece. I'm going to take half of it. Half of -4 is -2. And when I square that, I get 4. So I'm going to take x squared minus 4x equals -3/2. And I'm going to add 4 to both sides. Now the left side will factor as x is my variable. It's going to be squared. And then don't forget, this is going to be a -2 because what goes in here is the 1/2 of whatever the middle piece is, right? That x term. So that's going to be -2. On the right side, you may have to do a little bit of work here. We can make 4 with a denominator of 2 by multiplying by 2 over 2. So that would be 8/2. And -3 plus 5 is, sorry, plus 8 is 5. I'm doing the work in my head here. 5/2. Now you can go ahead and take the square root of both sides. So I have x minus 2 is equal to plus or minus the square root of 5/2. And you can add 2 to both sides. And we have x equals 2 plus or minus the square root of 5/2. Now, one thing here is we don't tend to like to have roots in our denominator. So this is 2 plus or minus square root of 5 over square root of 2. So we may want to rationalize that denominator here, and I can do that by multiplying by √2 over √2. What happens with this piece, you have a √10 up top and √4 in the bottom, right? 5 times 2 is 10, 2 times 2 is 4. And then √4 becomes 2. So I get 2 plus or minus √10 over 2 here. Now that is a valid answer. That looks good. I cannot break down the √10 anymore. Some people like to write this as one big group. If that's the case, then you could put the 2 over 1 here and multiply by 2 over 2 to get common denominators. And then I could write it as 4 plus or minus √10 all over 2. So that is correct. Or if you have the 2 separately, there's really nothing wrong with this either. It just depends on how we want our final answer expressed. So a lot of people like it as one kind of larger fraction. You would need to have common denominators to add it there. But again, this is not necessarily incorrect. It's just a different way to write that final version. And keep in mind that you have 2 answers, right? One is the positive version and one is the negative version. So the pro with completing the square is it does work in all quadratics. It doesn't have to be factorable. It doesn't have to have just the variables being squared. We basically can use any sort of quadratic, get it in the right position to start with, and then we can apply the completing the square formula.